Ever wonder how a simple glance could reveal more about you than you realize? Scientists are unlocking secrets hidden in the human eye, specifically the iris. This colorful, unique part of our eye isn't just for vision. It's a goldmine of data for cutting-edge research. Today, we're exploring how deep learning and clever algorithms are using iris patterns to guess gender, and why this could change how we think about identity, security, and even medicine. Let's start with the basics. The iris is like a fingerprint, but way more complex. Its patterns are so unique that the chance of two people having identical irises is 1 in 1052. That's like finding a single grain of sand in a galaxy. Unlike fingerprints, which can wear down, the iris stays stable your whole life. Plus, it's completely non-invasive, no need to touch anything. That's why it's a top choice for biometric tech, like secure logins or even airport scans. But how does this relate to gender? Well, researchers have found that certain iris patterns might hint at biological sex. Think of it like a hidden code. The process starts with capturing an iris image. Think of it as taking a photo of the eye. Then scientists break it down into tiny details, textures, lines, colors. These features are like clues in a puzzle. Traditionally, scientists handpick these clues using math formulas. But here's where AI steps in. Deep learning models like convolutional neural networks, CNNs, act like digital detectives. They teach themselves to spot patterns, getting better with every image they analyze. Imagine a detective who learns to read crime scenes on their own, improving with each case. These models can automatically pick out the most important details in an iris, making gender classification faster and more accurate. The results are impressive. A 2018 study used cell phone photos to train AI, combining multiple techniques to boost accuracy. By 2019, researchers were using powerful models like VGG16 to compare left and right irises, uncovering patterns humans had missed. And when they merged iris data with face and fingerprint scans, they hit a jaw-dropping 99.8% accuracy. It's like giving the AI a team of experts. Each modality adds a layer of certainty. But it's not all smooth sailing. Low-quality images, diverse populations, and ethical concerns still pose hurdles. Some systems struggle with blurry photos or fail to account for cultural differences. Plus, there's debate about how reliable these tools really are. So what's next? Researchers are pushing boundaries with advanced techniques like 3-level Haar wavelet transforms, which capture nuanced patterns invisible to the naked eye. Others are experimenting with hybrid models, combining CNNs with support vector machines or extreme learning machines, ELMs, to create super duos that outperform standalone systems. These ELMs, for instance, train lightning fast and require less tweaking, making them ideal for real-time applications. Imagine you're sorting a pile of puzzle pieces. A CNN is like a robot that quickly identifies shapes, but it might need help figuring out the right fit. That's where ELMs or hybrid systems step in, like a human assistant who knows the big picture and can spot the perfect match faster. This teamwork makes the system smarter and more reliable, even when the puzzle pieces are blurry or incomplete. And here's the kicker. The iris isn't just a biometric identifier. It's a window into biological traits. By analyzing how light interacts with the eye, or using 1D Gabber filters to highlight textures, researchers are developing systems that work even in low-quality conditions. This could revolutionize border security, smartphone authentication, or medical diagnostics, where subtle patterns might signal underlying health issues. The future of iris-based gender classification isn't just about accuracy, it's about redefining what's possible. As algorithms grow smarter and datasets become more inclusive, we're not just identifying people. We're uncovering layers of data that could reshape how we interact with technology, protect privacy, and even understand human biology. The next time you glance into a camera, remember, your eye might be telling a story you never knew it could.